Welcome to Module 17 of the Six Sigma Institute's Lean Six Sigma Certification Curriculum, which follows both the Council for Six Sigma Certification and the International Association for Six Sigma Certification Bodies of Knowledge. A full copy of the Council for Six Sigma Certification's Book of Knowledge can be downloaded from the course description section for free. In this module, we will be discussing the use of intermediate graphical analysis in Six Sigma. This module will take approximately 70 minutes to complete. At the end of this module, there will be a 5-question quiz on the topics discussed, which you can complete on your own at any time. You will also find several Six Sigma tools that you can download, including a histogram template and a chi-squared goodness of fit test calculator, both of which are Excel files. Graphical analysis is a critical part of the Six Sigma approach. Whenever data or ideas can be displayed in a visual format, obvious data trends can be quickly identified and communicated. Visual analysis is extremely helpful when presenting ideas to auxiliary staff or executives who might not be trained in intermediate or advanced statistics. The Black Belt or other Six Sigma experts have the ability to tell the same story that statistics tell, but in a format that can be understood by anyone. Visual depictions are tools that make it easier for Six Sigma professionals or sponsors to retell the story to others, which can be helpful for training, building cultural buy-in for process change, or even resource requests. In this section, we will discuss additional graphical analysis tools, including bar charts and pie charts. We will also take a look at scatter diagrams and how to create them in Excel, as well as how to manually create an X-bar chart using Excel. One of the biggest benefits of bar charts is that they are recognizable and easy to read. Almost any employee in a company can glean information from a properly formatted bar chart without instruction or guidance, making them a great choice for general use presentations and training materials. Bar charts are also easy to create, so they are a preferred method of illustration in presentations and reports. They typically require nominal or ordinal data, data that is classified according to qualitative information. When displaying nominal data, it is often beneficial to create a Pareto-style chart so that the reader can see instantly how the population relates to the categories. Ordinal data usually involves its own logical order for presentation. Bar charts are not without limitations, though. Depending on what is being presented, additional narrative might be required in order to explain the chart. Bar charts also often fail to reveal key information about trends that aren't part of the specific design of the chart, and they rarely, on their own, provide detailed data about causes or patterns within data. So let us create a bar chart using Excel. We can use the example from the book. We start by creating a table with 2 columns of data, each with a header at the top. The first column will be our frequency or duration, and the second column will be our bins of data. Once the data has been added, highlight both columns of data, including the headers. Up at the top, go ahead and select the Insert tab, and from there you can choose Charts. Now, you can choose any bar chart you want to create. In the example, we choose a standard vertical bar or column chart, but you can also choose a 3D chart, a horizontal, or any form of bar chart you want. Once you click OK, the chart will be automatically created for you and will be selected. Now, at the top of the ribbon, you should see the format options where you can customize the chart as you see fit. You may also manually change the labels, title, and colors of the chart if you want. Technically, what is commonly referred to as a bar chart, and what we've been calling a bar chart here, is actually a column chart. The visual columns representing each data category rise vertically. A literal bar chart displays the same information, but it does so on the horizontal level. Most versions of Excel let you choose between the two displays. The charts displayed so far in this module have all been two-dimensional, but Excel can also help you to create three-dimensional charts in order to add visual appeal to a presentation. Three-dimensional charts are helpful if you are presenting a number of similar-looking charts in a row, as it helps to differentiate between information in your presentation. It might also be helpful to create more visually appealing charts simply to capture audience attention more fully. Stacked bar charts let you display the total nominal or ordinal data for each category, while also breaking down that information into color-coded categories. For example, if the Six Sigma team analyzing phone calls per hour wanted to display data that included how many calls were handled by separate teams within a department, the bar chart might look something like the image you see here. Creating a stacked bar chart is slightly different from creating a standard bar chart, as you will need additional data columns. In order to create a stacked bar chart, you must have ordinal or nominal data that is broken into categories. The categories must be the same for each data set, so that the total of the subcategory numbers equal the total of the main category. So let's go ahead and add two new columns to the table we used when we created the bar chart, and add a column for Team A and Team B. You can copy the data provided in the Council for Six Sigma Certification Handbook that you can download in the course description section. The sum of the calls handled by the team, A and B, are equal to the total calls for each hourly segment in our previous example. Remember, when using a stacked bar chart, we are comparing two similar data sets. Now we need to highlight the cells with the data you want to include. In this case, we want the hour segments and the number of calls from Team A and Team B, but we do not need the total phone calls from the second column. We highlight all of the data, including the headers, as these headers will later become our labels in the chart. Now go up to the top ribbon and click Insert. Find the charts under the 2D columns. You will have an option for a stacked column chart. Go ahead and click OK, and the chart will be automatically created for you. Once it appears, it will be selected, and then you can format it using the Formats tab. You can change the color, title, and labels of the chart as you see fit. The pie chart is another visual tool that almost any employee in a business environment will be familiar with, making it a good choice for displaying certain types of information. Ordinal and nominal information can also be displayed in a pie chart with the main purpose of visually representing how each category relates to the whole. The fact that pie charts are used constantly in business environments is both an advantage and disadvantage for Six Sigma teams and experts. When data can be depicted in a pie chart, the Six Sigma expert usually has to create less narrative to get a potential point across. At the same time, pie charts don't always carry the weight that a more advanced statistical representation might, because business employees are so used to seeing them. Other disadvantages of pie charts include the fact that they can be manipulated in much of the same way as bar charts. They usually fail to easily display changes over time, and it can be difficult to visualize exact values when presented with a pie chart. So far, we have created a bar chart, a stacked bar chart. Now we are going to create a pie chart. And to do this, we only need two columns of data, one for the labels and one for the data. In the example from the book, our labels are the individual steps in a process, and the data are the minutes it takes to complete each step in the process. Once you have created the table, go ahead and highlight all of the data, including the headers. As always, in order to create a chart, we go to the Insert tab located above the ribbon and select Charts. The pie chart option should always be visible without having to select from a drop-down menu. You can simply click on it and the default two-dimensional pie chart will be automatically created for you. The totals of the data will be added up and everything will be converted to a percentage of the whole. All of this will be done automatically. Once the pie chart is created, it uses the default formatting, so you may have to make some changes to it. Up at the top, you will find the Format tab where you can change the colors and labels of the chart easily with a single click. Or you can manually change every aspect of the chart, the title, the individual labels, and even the individual colors. As with bar charts, you can take advantage of Excel options for creating three-dimensional pie charts. A particularly helpful function is the pie in pie function in Excel, which lets you create an overall pie chart and carve out a second pie chart to delve deeper into certain areas of the larger structure. Scatter diagrams are beneficial because they help teams visually see the relationship between two factors in a process. Does temperature decrease over time? Does a person's productivity increase with his or her salary? It's important to realize, however, that correlation as depicted on a scatter diagram doesn't necessarily mean causation. Two variables can be closely related without one causing changes in the other. Scatter diagrams help teams see whether there is no correlation, weak correlation, or a positive or negative correlation. Positive correlation occurs when variable 2 is related to an increase in variable 1, or vice versa. Negative correlation occurs when variable 2 is related to a decrease in variable 1, or vice versa. The drawbacks of scatter diagrams are that they are not as familiar to business employees as bar, pie, or even line charts. There is also a risk that individuals who don't have an understanding of statistical analysis will mistake correlation for causation, which can lead to incorrect decisions. We previously discussed correlation and regression on numerous occasions, so now it is time for us to create a scatter diagram in Excel. And to do this, we can use the example from the book. We will need to create a column with two sets of data that we are going to compare with a header at the top of each data set. In this case, our data will be the rate of parts produced per hour and the number of defects discovered when operating at that specific rate. Once you have created the table, go ahead and highlight all of the data, including the headers. Once the data is highlighted, up at the top, select Insert from the ribbon and look for Charts. Here you will find the available scatter charts. There are many different options to choose from, but we just want to use the basic scatter diagram. Go ahead and click on it. The scatter chart will be automatically created for you using the default design of the template you are using. As always though, you can change the chart using the format options, where you will be able to change the title, adjust labels, and of course, change the color in any way you want to. From the scatter diagram created, we can see that the two variables, production volume and errors, appear to be related in some manner. Well, it is a good bet that increased production actually causes increased errors. You can't simply assume causation from this graph. This assumption could be further tested using more advanced statistical techniques. It should be noted that even when correlation seems obvious on a scatter diagram, it isn't always the case. Six Sigma experts should always test correlation assumptions to ensure that they are correct statistically before presenting a scatter diagram to others as an illustration of a relationship. The X-bar control chart plots the mean of a sample over time, or the mean of samples taken over time in the case of an active process. X-bar control charts are one of the most frequently used control charts. Some control charts can also be created in Excel using these steps. More advanced control charts require statistical analysis software. We have included many different Excel control chart templates in the download section for you. Now, this is going to be one of the most complex charts we will be creating using Excel. So, let us use the example from the book so that you have an easy reference to follow. In column A, enter your data points. In cell G1, enter the formula equals STDEV, open and close parentheses. Then select the data points from column A and hit enter. In cell G5, enter the formula equals AVERAGE, open and close parentheses. Then select the same data points from column A and hit enter. In cell G2, enter the formula equals G5 plus 3 asterisk G1 in parentheses. Then hit enter. In cell G3, enter the formula equals G5 minus 3 asterisk G1 in parentheses. Then hit enter. In column B, the upper control limit column, enter equals $G $2 in the first row. Then copy it to each row. In column C, the lower control limit, enter equals $G $3 into the first row, then copy it into each row. In column D, the mean column, enter equals $G $5 into the first row, then copy that into each row. Now we need to highlight all of the data from columns A, B, C, and D, including the headers. This will highlight the data points, the mean or average of the data points, and the upper and lower control limits, which will be the 3 standard deviations above and below the mean. There is no option to insert an X-bar control chart, or any control chart for that matter. So we will be creating the entire chart manually from a line chart. Click on the Insert tab above the ribbon and choose Line Chart. Then select the two-dimensional line chart with markers. The default chart will be created with 3 horizontal lines. The one in the middle is the mean, and the ones above and below the mean are the upper and lower control limits respectively. The line that moves around represents your data points. But this chart does not look very good, and it's hard to understand as is. So we will need to format it more than any other chart we have created so far. Start by right-clicking in the data label for the y-axis and choose the option Format Axis. Here, you will be able to alter the bounds of the axis in order to remove excessive white space that is located below the lower control limit. That space is a waste, so we can remove it by adjusting the bounds minimum from 0 to 15. Since the top looks fine, you can leave it alone, or to make it appear more even, you could increase it to 37 or 38. This would give you an equal amount of white space above and below the chart. Now, you can format the colors, title, and data labels as you see fit. If the data point's line color is too similar to the mean, go ahead and change the color of the mean line. Once this is done, we can add in the 1 and 2 standard deviation lines above and below the mean. Since we are missing the 1 and 2 standard deviation lines from above and below the mean, we need to add these to the spreadsheet. In order to do this, you need to right-click on E at the top of the E column and choose Insert. Do this 4 times to create 4 new columns. The cells that were in G should now be in K. So, in cell K8, enter the formula equals K5 plus 1 asterisk K1. in parentheses, then hit enter. In cell K9, enter the formula equals K5 plus 2 asterisk K1 in parentheses, then hit enter. These will be your 1 and 2 standard deviations above. Now, in cell K10, enter the formula K5 minus 1 asterisk K1 in parentheses, then hit enter. And in cell K11, enter the formula equals K5 minus 2 asterisk K1 in parentheses, then hit enter. These will be your 1 and 2 standard deviations below, as we did for the upper and lower control limits, as well as for the mean. Enter into the first row of column E equals $K $8 of column F equals $K $9 of column G equals $K $10 and of column H equals $K $11 and copy all of those to the rows below. This time, we want to highlight all of the data that is in columns A through H, including the headers. Then once again, we will select the Insert tab from above the ribbon and choose the two-dimensional line chart with markers. We need to get rid of that white space, so go ahead and right-click on the y-axis labels and adjust the bounds as we did the last time. This time, since we have the extra lines, we want to format them, so go ahead and right-click them and select the gradient option under the line section and choose the None option under the market line. This will remove the dots from the 1 and 2 standard deviation lines above and below the mean line and make the data points stand out better. You can also remove the markers from the upper and lower control limit lines as well as the mean line if you wish to do so. Lastly, we want to go ahead and edit the finished chart by changing the title and modifying the labels as you see fit. You can complete these calculations by hand, but that can be time-consuming and require extremely advanced statistical skill sets. We will start with manual calculations because it helps us to understand the reasoning behind it and analysis. But we will also rely heavily on tools that complete most of the calculations for us. Not only does statistical analysis software minimize the time it takes in order to conduct such analysis, but it also reduces the chance of calculation errors and increases the accuracy of analysis and conclusions offered by Six Sigma experts. For most users, this tool may already be activated in Excel, but if not, we can go ahead and add it. So, as long as you are using Excel 2013 or newer, at the very top, simply select File just like you would if you wanted to save a newly created file, but this time, go ahead and click on Options. Here, you will be presented with all of the Excel options, and there are a lot of them. Near the bottom, you will find the Add-ins option, and you want to go ahead and click on it. A pop-up dialog will be presented to you. Look for the Analysis Tool Pack. If it is not already enabled in your Excel, then it will be under the Inactive Application Add-ins. Otherwise, it will be under the Active Application Add-ins. If it is already active, then there's nothing else you need to do. If it is not active, then at the bottom of the dialog box, select to manage Excel add-ins from the drop-down and click Go. A new dialog box will pop up and will show you a number of available add-ins with radio checkboxes next to them. If the Analysis Tool Pack already has a check mark, then it is already active and you just need to click OK. Otherwise, go ahead and check the box next to the tool pack and click OK. This will make sure that the tool pack is already installed, and you can verify this by going back to your spreadsheet and selecting the Data tab above the ribbon. You should see Data Analysis option on the ribbon. This tool pack includes tools like Analysis of Variance or ANOVA, correlation analysis, histograms, regression analysis, the T and Z hypothesis test, and even basic sampling calculations. While it is not as robust or easy to use as Minitab, it is a lot cheaper. We will discuss Minitab later, and while I recommend it, the current price for a licensed copy is exorbitant.